Today, our team will be presenting a comprehensive horticultural crop management plan for oranges. My name is Ella Joseph, and I'm joined by my team members Maylee Ladd, Sana Harris, Mason Jenkins, Preston Vaughn, and Avery Roan. Over the next few minutes, we'll take you through everything you need to know about successfully growing and managing orange crops, from understanding the plant's background to harvesting and post-harvest practices. Let's get started. Here's an overview of what we'll be covering today. First, we'll begin with an introduction and background on oranges. Then we'll discuss the growing requirements like the climate, soil, water, and temperature that oranges trees need to thrive. Then we'll move into crop management. After that, we'll explore harvest and post-harvest practices. And then we'll wrap up with our conclusion, summarizing the key points about orange production.
Hi, I'm Sanai, and today we're going to be talking about oranges. Oranges, also known as Citrus sinensis, originated in Southeast Asia. They made their way to the U.S. in the early 16th century. Oranges generally have a high environmental impact/carbon footprint compared to other crops. This is due to the use of pesticides and fertilizers. Their land usage, as well as their long growing seasons that require lots and lots of water usage.
Here are the growing requirements for oranges. As far as the soil goes, it needs moist soil with enriched organic matter. Like stuff you buy from the store has a lot of organic matter and would help oranges grow. Sunlight, lots of sunlight grows best spring, summer, and fall. Places like California and Florida, where there's don't get a whole lot of rain, really sunny throughout the year. Water, about 1 inch of water per week, so not a lot. And if your leaves start to yellow on your orange trees, it may indicate overwatering and potential disease. Temperature, the optimal temperature is between 60 and 90 degrees. Like I said before, California and Florida are optimal for this, and that's why those two states grow the most in the country. Thank you.
Now let's talk about pest and disease control strategies for orange production. This is a critical aspect of crop management because orange trees face numerous threats that can significantly impact yield and tree health. These threats fall into three main categories: fungal diseases like anthracnose and root rots, bacterial diseases including citrus canker and citrus greening, and insect pests such as the Asian citrus psyllid and aphids. To effectively manage these threats, growers use an integrated pest management approach, or IPM, which combines prevention, regular monitoring, and various control methods. Starting with fungal diseases, there are three major ones that orange growers need to watch for. First is anthracnose, caused by Calotrichum gloeosporioides. You can see in this first image on the top right the characteristic discolored streaks on the orange rind. These streaks are actually caused by the hyphae, or fungal threads, of the anthracnose pathogen. You'll also recognize this disease by premature leaf drop and dark fungal spores covering the leaves. This disease is especially common during wet springs, so fungicides should be applied during these high-risk periods. Second is brown rot, caused by Phytophthora species. This one affects fruit close to maturation, causing water-soaked lesions that turn brown and produce a distinctive pungent smell. Management focuses on cultural practices like reducing leaf wetness through proper mowing and irrigation, along with copper fungicide applications. Third is malaria root rot, also called mushroom root rot. This is a serious disease, and as you can see in the second image, one of its telltale signs is these clusters of malaria mushrooms that appear at the base of affected trees. You'll also see trees wilting, chlorotic leaves dropping, and overall tree decline. Unfortunately, once established, it's difficult to control. Infected trees must be removed along with their entire root system, and you need to wait at least 1 year before replanting in that location. Now we need to talk about the most serious threat facing citrus production today: huanglongbing, commonly called citrus greening or HLB. This deserves special attention because it has the potential to devastate the entire citrus industry. HLB is caused by bacteria called Candidatus liberibacter. Looking at the map on the right, you can see the areas of quarantine for citrus greening and the Asian psyllid in the United States. Notice how extensive these quarantine zones are, particularly in the southeast and parts of California. This really illustrates just how widespread this threat has become and why strict movement restrictions are necessary. The symptoms include yellowing of leaf veins, blotchy modeling patterns on leaves, and perhaps most notably, misshapen and lopsided fruit that develops a bitter, salty taste. In the second image on the bottom right, you can see the symptoms of citrus greening on an orange tree. Notice the yellowing patterns and the overall unhealthy appearance of the foliage compared to what a healthy tree should look like. Trees also experience premature fruit drop and overall decline. Here's what makes this disease so devastating. It's spread by the Asian citrus psyllid. And here's the critical part. There is no cure. Once a tree is infected, it cannot be saved and must be removed to prevent further spread. Since there's no cure for citrus greening, prevention is absolutely the only strategy we have. For cultural control, quarantine measures are essential. This means restricting the movement of citrus plants, fruit, and equipment in affected areas. When infected trees are identified, they must be removed immediately and destroyed. Regular scouting is critical. Growers should inspect their groves at least 4 times per year to catch infections early before symptoms even appear. But the most important management strategy is controlling the vector, the Asian citrus psyllid. This involves applying systematic insecticides at the base of the tree trunk, which has proven very effective. In the United States, areas called Citrus Health Management Areas, or CHMAs, have been established where neighboring growers coordinate their spraying efforts for better control. Some areas are also using biological control methods, like releasing parasitic wasps that attack the psyllids. The key message here is that psyllid control is not optional. It's absolutely essential for protecting citrus groves from this devastating disease. Speaking of the Asian citrus psyllid, let's look more closely at the major insect pests affecting oranges. The Asian citrus psyllid, Diaphorina citri, is public enemy number 1 because it's the primary vector of citrus greening. In the first image on the right, you can see an Asian citrus psyllid on a leaf. Notice how tiny these insects are. These insects are only about 4 millimeters long with a mottled brown appearance. They feed at an angle to the leaf surface, which makes them look like thorns on the plant. What's alarming is how efficiently they transmit the disease. A psyllid can acquire the bacteria after just 15 to 30 minutes of feeding on an affected tree and can then transmit it to healthy trees. For commercial groves, regular insecticide applications to control psyllids are absolutely critical. The other major pest is the black citrus aphid, Toxoptera auranti. These cause leaf curling and produce a sticky honeydew substance that can lead to sooty mold growth. They also transmit Tristeza virus. However, aphid populations usually decline naturally as leaves harden and trees can tolerate quite a bit of leaf curling, so pesticide applications are generally not recommended for aphids and they're much less of a concern compared to psyllids. Now let's bring this all together with an integrated pest management approach. IPM starts with prevention. This means always using disease-free budwood for propagation, planting trees in well-draining soil to prevent root diseases, and conducting regular scouting and monitoring throughout the growing season. Cultural practices are the next line of defense. Growers should focus on reducing leaf wetness by mowing around trees to keep grass short, pruning low-hanging branches off the ground, and managing irrigation carefully to avoid creating conditions favorable for disease. Installing windbreaks can also help reduce the spread of diseases and pests. You can see in the first image on the right an example of gardening netting used as a green windbreak net. These physical barriers help protect trees from wind-driven rain that can spread bacterial diseases, and they can also reduce pest movement between areas. Chemical control plays an important role when needed. Copper fungicides, like the liquid copper fungicide pictured on the bottom right, are used for bacterial diseases like citrus canker, and systematic insecticides are essential for controlling psyllids. These should be applied during high-risk periods, such as wet weather for fungal diseases or when psyllid populations are detected. Finally, rapid response is crucial. When disease is detected, infected trees must be removed immediately, and all diseased plant material should be destroyed. Because many pests and diseases spread between neighboring groves, it's important to coordinate management efforts with surrounding growers for the most effective control.
On this slide, we're looking at crop management, specifically the pruning and training techniques used for citrus trees. First, growers remove any dead, diseased, or crossing branches. This improves airflow through the canopy, which helps reduce fungal disease pressure. This also supports integrated pest management strategies. If you look at the illustrations on the right, you can see a comparison of the tree structure before and after pruning, showing how opening the canopy reduces crowding. Second, the canopy is shaped into an open, vase-like structure. This form allows more sunlight to penetrate into the center of the tree. Better light exposure directly improves fruit quality and size. Third, when trees are young, growers maintain a strong, single central leader. As a tree matures, they allow evenly spaced scaffold branches to develop. This creates a balanced, strong structure capable of supporting fruit. Finally, trees are pruned annually after harvest. This helps keep tree height manageable, encourages new fruiting wood, and makes spraying and harvesting easier. In the bottom image on the right, you can see a worker actively pruning branches, demonstrating how this practice is done in the orchard. Now moving on to harvest and post-harvest practices. First, fruit is harvested only when it reaches full color and the desired sugar level. This is usually done by hand to avoid damaging the peel. In the image on the right, you can see someone hand-picking an orange carefully from the tree. Second, instead of pulling fruit from the branch, workers clip fruit stems. Pulling can tear the rind, which increases decay risk. Clipping helps maintain fruit quality during the storage and transport. Third, immediately after harvest, fruit is cooled in a process called pre-cooling. This slows respiration, meaning the fruit breaks down more slowly, which extends its shelf life. Lastly, fruit is sorted, washed, and graded before packing. A thin, food-safe wax coating is often applied to reduce moisture loss. At the top right, you can see an example of a packing line where fruit is washed, processed before distribution.
Howdy, my name is Naily Ladd, and I will be going over the conclusion. So, to recap, Citrus sinensis, or more commonly known as oranges, is a fruit from the southeast region of Asia. For oranges to thrive and survive, of course, they have to have certain conditions to live along, like moist soil that is abundant in organic material, about an inch of water every week, as much sunlight as possible, temperatures between 60 and 90 degrees Fahrenheit, and because of these reasons, they grow best from spring to fall in places like California and Florida. Unlike other crops, oranges have a much higher carbon footprint. This is for many reasons, like the use of fertilizers, pesticides, large acreage needed, and a high water consumption. So, unfortunately, oranges face a lot of diseases that can be caused by fungi, bacteria, or insects, and the illnesses that they carry. For fungal infections, fungicides are used, as well as proper irrigation and removal of the infected, which is, besides the fungicides, is the same way that a lot of bacterial and insect illnesses are also removed. However, the biggest threat to orange trees is still citrus greening HLB, because no cure currently exists, and the devastation can be huge by wiping out entire fields of orange trees. Prevention is the only way to stop the spread. And of course, insects causing these diseases are treated by insecticides. Pruning is one of the best ways to keep oranges healthy by removing dead or deceased branches, which is, again, going back to the points above, another way to keep plants healthy despite whatever diseases they may have. Anyway, for post-harvesting practices, it's best to wait until full maturity to harvest oranges, but it depends on the sugar level you are going for. Clipping oranges from stems help to not harm the tree, but also not harm the orange rinds. Then they need to immediately enter pre-cooling practices. And lastly, food-safe wax needs to be added to stop the moisture from leaving the oranges. Thank you.